In the last video, we created all the elements for the text. Now we're going to move on to the fish. We're going to do a look dev and then rig it and animate it. Let's drop a geometry node. Let's hide these for now because we don't really need to see this. And call this fish. Let's go inside and then drop a file node. So if you go to the project folder and if you go to the geometry folder, there's actually a geometry called fish under the fish folder. So let's grab that. And also, if you go to the texture folder, there are some of the JPEGs and PSDs that I worked on before this. And we're gonna, so basically I did some color correction in Photoshop and we'll be using these textures later. So let's just grab the fish model for now. Okay. So this is just a very generic dragonfish model placed at the origin. And if you look at the dimension, it's huge. So this often happens when you bring something from Maya or Max into Houdini. So let's scale this. So let's scale this to 0.01. All right, something like this. And then let's go back and turn on the contour and the cross because these are pretty light. To show all the objects. Okay, so this is still kind of too big, so let's just transform it even smaller to something like this. All right, so let's take a look at the topology here. Apparently, there's going to be some problems when we animate this. So some of the geometry topology are not very good for animation. So we're going to do remesh, subdivide, all kinds of stuff later. But for now, let's just go ahead and copy all the nodes from the original setup we have here. And we're going to use some of the elements. So for this case, we're going to use the voxel, and we're going to use part of the contour. But because this is not like a cube shape, so we can't really just copy it along z-axis. It's not that simple. And then we're not going to use the cross because it doesn't really work that way. And we're going to dump the fog as well. So I'm going to go ahead and copy. I'm just going to grab all the nodes here for now. And we can just pick something that we're going to use. All right, so let's plug this in. So a lot of the stuff here, we can just dump them. For example, we don't really need any extrude. Let's just, and we don't need any box either. Transform, no, we don't need the polybevel, no. We just need to put this in the box. And let's just get rid of all these, and we're not going to use the VDB combine and all that stuff. And we're also going to drop the offset as well, because there is going to be a lot of animation happening on top of the fish. So there's really, you can try to keep them, but I find that kind of a bit too much to keep the flickering effect. And we're going to drop the cross. Well, and the fog, we don't need those either, so we're just gonna keep these. And so for here, for this part, let's just keep it for now. Let's worry about this part later. Okay. All right. This is non-time dependent. Okay, great. So VDB from polygons. So we're gonna run into some problems. Number one is you can see that the voxel size is definitely not enough because we're missing all the fins, even though we actually plug all the stuff in. So let's drop the voxel size to half of it. Still, you can see that they're very light. We can see something here, but not enough. And the next step is, let's see, when we run these, again, we're gonna run into a problem because this is just way too low. The volume density is way too low. Okay, so here we're seeing something. Another problem is because originally the way we built this setup is that we're using relative to box to be divided by a unit, and the unit for x and y direction are the same. So you can see that we're getting this result that the voxels on the y direction, they're compressed compared to the x. But you know, we want little cubes instead of this. So let's go inside the volume VOP to tweak some of the stuff. So all we need really is just we just need to, so here when the x-axis is modulo by the unit, let's just put a multiply here. So we just multiply on the x-axis, and let's promote this, and let's just call this x multiply. X multiply. All right, and let's just put something like let's put 4 there. All right, so this is kind of doing. And another thing is the unit is a little bit too dense. So let's just increase this. Okay. All right. So here we get something we like. It's the every box are kind of like a cube now, and it's not condensed. And the next step would be, because this thing it just looks like the kill ramp is a bit too much. We don't want so much stuff to be missing, so let's change something here. So let's put this value up to something like this. Okay, so it's filling some of the area because we don't really need that much kill. Maybe we can try something with this is fine for now. Okay, and the frequency, let's try something like this. Okay, and the overall, the density frequency, let's do something like this. Okay. All right, and then if we convert to VDB and we get points. Okay, and let's see what else so here it's just the same thing. We split it, and then we do a cluster. Do a cluster here. Okay, and then these are the same, and let's see what we get here. So this is so we might want more. Let's see this one here. So one of the biggest problem here is you can see the tail and the fins are really thin. So the points we get are pretty flat. So when we convert these to volumes, we might run into problems. So we're going to have to modify the original model a little bit. Also, this whole thing, we can't just put a one color on it. We actually want to do some kind of color palette to compensate the overall blue tone. So we're going to go back to the model and use the texture and do something with the look of it. So let's get started. So let's go back to the original fish model. And let's just pull this thing up. And let's just get rid of that for now. Actually, so let's drop a connectivity node here. And let's put a color just to see the connectivity of the original model. So random class. Okay, so this is how everything is divided into different sections. All right, so let's put a split node here. Let's isolate each areas first. This one, let's do points, and then you can, so basically you can go ahead and take a look at the geometry spreadsheet and kind of see which area is which. So let's do attribute class equals to 0, 1, 8, and 9. So this is the fins, and let's invert the selection. Okay, so we've got the main body. Then let's put another split. Here, let's drop a null node. Let's do another split class. Actually, let's delete unused group as well. So let's put class equals to 2, 3, 4, and 5. So we get the main body. And the back fins are divided. Okay. And let's do a split again. Oops. So this one, let's do points class equals to 3. All right. Let's invert the selection. So this thing is very thin. So let's put a transform here. And let's drop a centroid here, CX, CY, CZ. And then let's scale the Z direction for 5. So it's a lot thicker. So this way we get a cleaner result for the volumes, the point cloud later. Okay, so let's drop a color node on it. So what I'm going to do is I'm going to drop a color, and then I'm going to use one of those textures to add on top of the color. I'm going to use a multiply so that it's going to have one solid color, and then it has some kind of ambient occlusion kind of pattern on it. So for that case, we want a pretty bright color to start with. So here you can see that I went above 1 here. This is really bright because once you multiply the texture, the color is going to drop a lot. So let's go to the point file. Let's drop a texture node. So we just plug the UV, texture, not texture 3D. Plug the UV in this. So let's take a look at the texture map here. So under the HIF folders texture folder, here are some of the maps This is the diffuse color, and the luminance is just a grayscale version I did in Photoshop. And luminance PSD is something that I just increased the contrast. There used to be a transparency as well. We might use them, we might not. And here are the maps for the fins and stuff. Okay, so here we're gonna grab the, just grab the luminance. And then we're gonna need the original color as well. And then, so this one, we're just gonna need the first digits of all three. And then we just use the, let's just multiply the original color. And then put the first one in it. And just plug that into the color. And then let's put a parameter here. And just call this grayscale, because you might want to preserve the grayscale, and then we can use it sometime. Invisible. All right. So you can see that it's reading the texture, but it's really low res, and the reason is we need a subdivide here. Because the point count is too low. So let's just do 3 or no. Okay, so you can see that we get pretty clean result. So later we're gonna, after we create the box points, we're gonna use the point cloud to grab the color of this. So let's just make a group so that we can use this separately. So let's just call it torso, point group, star, and let's just put a reference here called torso. All right, let's so this section is done. In the next video, we'll continue applying color to the other section of the fish. In the last video, we split the fish into different parts and we colored the torso. Now let's work on other parts of it. So let's put a null node here to grab the back fin. Okay, so you can see that the topology is, there's gonna be some problems for this. So let's do a remesh. And for the target size, let's do 0.002. All right, so this is pretty good, small enough. And then let's put a transform here. And let's put the CX, CY, CZ, and we can scale this on Z direction just to get a thicker result. And then let's check the connectivity. Let's put a color here. And then random from attribute class. So you can see that the connectivity is lost. So let's just put the connectivity node again. All right, so we get the connectivity. So the problem with this mesh is if you turn on the template of the fish body, you can see that this area actually goes inside to the belly of the fish, and this is gonna cause you problems. So let's get rid of the parts that goes inside. So let's do a group node. The first input is this, and the second input is the fish model. Now let's do inside, points, keeping bounding region, bounding object. All right, and let's just peek the fish body just a little bit backward, negative 0.001. So it doesn't leave a seam for us. Okay, and then now let's work on the two parts separately. So let's put a split, and let's do points class equals to 1. All right, let's put a null there. So the plan here is I'm gonna get rid of this part first, and then unlike how we did the fish torso, we just put one color. This one I kind of want to throw a little bit of blue on it, and based on the distance to the torso, so we need to isolate this area, these points as well. So let's do a blast. Let's get rid of the inside points. Get rid of the unused group as well. Okay, and then let's do a group again. And then edge, open, and turn off this. Just turn on include by edges, unshared edges. So what this does is it's gonna isolate the opening for us. So if you go blast and just do open, edges, delete non-selected. So you can see that this is isolating the edge. And now we can drop a point blob and do some color stuff based on this. So first of all, we're gonna need the same treatment we did in this one. When we apply the color and then we just multiply the texture, we're gonna need the same thing. So let's just copy paste these, put it in here. For now, it doesn't have any colors. So if you just plug this in, so we're gonna need some other treatment. So here that you can see that the UV is plugged, not right. So we need the actual UVs. All right, so we get something. The texture is working, and now let's do a point cloud to read the edge points position. So let's do a point cloud. Open, and then let's just manual mode. Okay, so the file is the second input, and actually let's put it on top. And the position is the current position, and let's promote the radius. And let's see, number of points 3, co-angle 360. All right, so let's do a point cloud, number find. So compare this to 0, greater than 0. So if this is greater than 0, then we're gonna do something with it. All right, let's push these back. Somewhere here. And then let's do a point cloud, import by index. And here we can put a signature float. And let's put point dot distance. So basically, it's gonna calculate how far the points is away from this edge. And then let's just do a divide. Divide this by the radius. And then let's do a ramp. So let's do a ramp. So let's just call this radius ramp. Radius ramp. All right. And then let's actually use the this radius ramp to multiply the compare. Okay. And then let's put another color here. So let's put a ramp parameter. So this time, this is the actual color of it. So basically, this is gonna be blue and yellow. Let's put that, and then for now, let's just kill the grayscale for now, and let's see what we can get. All right, now let's go aside and tweak some of the settings. All right, so the search distance, let's do that, and then the radius ramp, let's do something like this. And the color ramp, let's do some color here. So we need, we're gonna need 3 color here. So the first one, let's do 2.2, and then 5.16, and then let's do 10. And the second color is gonna be 2.26, 2.44. 2.90. So the way you pick these color is, so first of all, you can pick a color around here. Once you get the hue you like, you can go here and just bump the V above 1. So you can go like 5 or 10, and then you can get a pretty bright color. And then the third one, we're gonna do 5. 0.96 and then 0. All right, so let's see how it looks like. Okay, so it's really bright, and the reason is because remember we need to multiply this with the texture. So here, the color, we need to plug the first color in, the texture, and let's put the color in. All right, so we get something like this. And I think it looks a little bit too even for me. How the yellow and the orange and the blue, how they are divided, is just a little bit too even for me. So what I'm gonna do is I'm gonna go ahead and go inside here, and I'm gonna do add some noise to the position of this point cloud. So I'm gonna do a anti-alias full noise. So the position is just gonna be the position, and then let's promote the frequency, offset, amplitude, roughness, and this is gonna be a 3D noise. And then let's add this on top of the original position, and then plug this into the position. So what this does is when it's reading the file, which is the second input, the open edge, it's gonna distort the position first. So the result you're gonna get is you're gonna get a distorted result here as well. So here, let's for the value of the frequency, let's just copy, paste relative reference. Let's put like a 10 here, and then so this is just like, you can see that this is a little bit too much because the amplitude is just way too high. So we just need a little bit, something like that. And then let's put roughness down to somewhere here. Okay, so if you compare the previous result and then the current one, so I'm adding some noise on it so that this doesn't look that even, how the blue and the yellow are divided. And so I did another thing here, which is because I really like the definition of these thin lines. So I went ahead to color correct the luminance texture again. And then, so here inside the point VOP, so I basically just copy the texture here, And we don't want this grayscale actually. So here, instead of the luminous JPEG, I did the luminous PSDs, which is I increased the contrast a lot, and then I multiply the first input to this multiply. And then, so what I'm trying to do is I kind of make these lines sharper, and I kind of want the color to blend in, so that the way the blue and the orange, the way they mix, I kind of want them to follow these patterns again. But you can see that this is the value of this first input needs to be tweaked. So let's put a parameter, ramp parameter here. Parameter. And let's just call this texture ramp. Texture ramp. So we're gonna use the spline here as well. Okay. And then if you go here, the texture wrap. So here the value, let's put 1. And then let's change it to Catmull ROM. And then it did a curve, something like this. All right, because I kind of wanted the orange to blend in the blue and with the thin lines just a little bit as well. All right, so once we get this, what you can do is you can just copy and paste to the other one. And again, you're gonna have to tweak the values here because the distance, the radius, and everything, it's pretty different. But let's see what we need to change here. So first of all, let's change the distance to something like this. And the frequency, let's do something like that. Okay, and then the offset and amplitude, everything's fine. The texture ramp, well, let's worry about this later. The radius ramp, this is fine. And so we kind of want to tweak the color ramp here a little bit. So what I did was, so I kind of just, let's pick another color here and then set this like this. So I did something like this because I wanted the blue to just fall in the center and the yellow to be, the orange to be on both sides. And then, okay, and let's continue and see what we need to change here. All right, the texture ramp, let's increase the tip of this. Okay, and then the radius ramp. Let's see, something like this. Okay, so this is the blue in the middle, and then the orange on both sides. Okay. Let's see, something else I need to change. All right. So you can definitely spend some time tweaking these colors. And let me actually copy paste the color here. So just copy and paste relative reference. Paste relative reference. All right, so this is brighter actually. Okay, so let's just merge these for now. And then because they have open areas, so let's do a polyfill. So this is gonna fill the geometry. Let's actually do triangles, which is actually fine in this case because this is so high res. And let's do a faucet and post compute normals. And then let's do a peak. And then let's just peak it a little bit so it's thicker, you know. All right, so that's all we need to do for this area here. So let's just do the same thing. We're just gonna name it and then put a group on it. So I'm gonna call it, this is torso. So I'm just gonna call this tail. And then this is called tail. Okay, so let's keep working on the other part. So let's work on the fins here. Again, we're gonna need a split here. Let's split it. So let's just do points, class equals to 0 and 1. Delete none groups. All right. Whoops. Okay. So this, we're gonna do the same thing here. So all we need is we're gonna remesh it or subdivide it, depends on the topology, and then we're gonna apply the colors to it, just like how we did in this point blob here. We don't really need all these anymore because we don't need to do any kind of cleanup or color or anything. So let's continue to work on these parts in the next video. In the last video, we worked on these two parts of the fish. Now let's continue to work on the look dev of the rest of the parts. So here I'm just repeating the process I did in the previous two videos. I'm just remeshing or subdividing it and then copy paste the texture node. So the fins do have their specific textures. And then I'm gonna rename the groups and then same thing for the thinner fins. So this one used the blue color here. And then rename the groups and everything. So once you're done with everything, make sure to put a rest position node. So rest position on both of these. So they're gonna come in handy at some point. And then for the animation, we're gonna actually animate this part first and then use this part to drive the fins. So let's actually rename this part as the main. And let's rename the fin part as the fin. And then let's merge these two. And then let's do another null node and just call this let's call this body static. So once we have the body static ready, we can plug the body static to the process of how we generate all the points. And then let's cook this thing again. All right, so this is something that we got. And now let's grab the color from the body static. So let's put a object merge. Just call it OM body static. So let's just do into this object / body static. Okay. So we're going to use a point bob here. Let's drop a point bob. Again, we're going to use a point cloud. So let's go inside and let's do point cloud open. Second input as the file, position here, and then promote the radius, and then number of points 3, count angle 360. That's good enough. And then point cloud, input by index. Here we're going to use color, and then we're going to put this color into the CD. So there is one problem here, that is, remember the static is just a surface, right? There's nothing inside, but our points, there's actually stuff inside. So what we can do here is, because we mostly view the fish from on Z direction. So what we can do is we can zero out the Z axis. So we can go inside, and here, what we can do is we can do a vector to float, and then float to vector. And we just keep the X and Y plugged. And then we put this new one into the position. And then we can go outside, and so for this one, what we can do is, let's put a point run, go here. And let's just say vector P equals to set Px, Py, and 0. So we're just gonna dump the Z-axis. And then, so it's, you can see that it's all flattened. And here, it's gonna grab the color for us, and then we can plug the color in. And you can try to increase the radius if you want. And so this is what we get for the boxes. And if you feel like some of the areas you want more lines or anything, you can go ahead and tweak this in here. And then later, when we generate the volumes, what we can do is, because this is already linked to the original, the first volume we did, but this is a slightly bit too high. So I would actually go for like 2 multiply this. And then what we can do is we can keep the density, and we can actually use the color to generate a color volume. All right, let's put a volume visualization node here. So there's density in it, and the color in here. And you probably need to bump this up a lot. Okay, so we get something like this. Again, this doesn't really represent what you're gonna see 100% in the renders. And then we will actually come up with the animation on the original fish model and use that to drive the points, and then we can generate the volumes. Now we can render this just like how we render the fog volume. So the material will pick up the color, and you can adjust the density as well. In the next video, we'll take a look at how we can create the look depth for the contour of the fish. In the last video, we finished the look depth for the volumes of the fish. Now let's work on the contours. So let's go ahead and grab the main part, and let's put a clip node here. And let's put this one on the right. We might reuse the contour setup we had before. Okay, so let's change this. So the origin, we just need to change this to the centroid of the main. which is the body and the back fin. DC, right? And the direction we're gonna do the Z, positive Z direction. Okay. And then we're gonna keep the primitive above the plane, that's fine. All right, so let's do a group. For the group, let's do edge, open, and then we're gonna do the include by edges, unshared edge, just like we did before. And then let's do group promote. So we're gonna promote the group from edge to points. And then let's do a blast. Get the open. It's going to be points. Delete non-selected. All right. So we get these, and I kind of like that it keeps the eyeball as well, which is pretty nice. So let's put a merge note here. And for the fins, because it's really not very procedural, there's really no way that you can cut it. So we're just gonna have to manually select it. So let's push this part to the side a little bit. All right, so here, first of all, we're gonna do, we're gonna need the faucet. And then we're gonna need the peak as well. Okay, so we get something like this. All right, and then let's do a subdivide. Now let's do depth 3. And then here, if you want to keep the original shape, what you can do is you can do a override crease weight attribute and just put the crease edge to 10. Just like how you do it in Maya, you can crease the edge loop to kind of keep the shape. And then we're gonna select the edge group and call it a new group. So make sure that you're under the edge. And then let's double click to select this edge loop here. All right. This section here. Hold down Shift to add selection. Okay. So this side, Shift, double click. All right, so let's hit Tab and do a group. Let's just call this open. And then we can basically do the same thing here. So let's just copy and paste. Now we don't need this one. Just gonna promote to the points, and then we get the points. But this leaves us one problem. This is white. It doesn't have any colors. So let's put a attribute copy here, and let's just plug the peak in here, and we just copy the color. All right. So this is for the bigger fins, and now let's work on the thinner ones. So the thinner ones, we can just go ahead and go to the peak, and then let's select the edge loop. So this one we can actually pick the one that in the center. Okay, and then this one. All right, this should get all the stuff. Okay, cool. Let's drop a group and then call this open. And we can do the same thing. And we don't even need to worry about the color this time. So we want to put it to the side. This one, okay. And let's merge these two. All right, so we get something like this. And so there's one thing, because we did a lot of stuff with the fins, and I kind of like these darker shapes. So I'm going to try to keep some of these as well. So I'm going to put down a delete node under the peak. And here, points, delete by expression. And here I'm going to do cd.r is less than 0.4. So delete none selected. All right, so it's kind of keeping some of the points. And let's drop a add node to just keep the points. And then merge to the whole thing. All right, so we get these. And now we can merge the whole thing to this one. Okay, so it still looks a little bit empty. We kind of want to still, keep the tube shape of the fish a little bit better. So let's do something else to kind of preserve the side profile of the fish. So let's drop a circle here. And then the direction, so we want a YZ plane, and then we want a polygon. And then the division, let's do 48 because we want a pretty smooth circle. Okay, let's do open arc. Okay, and for the size, let's just copy the first one and paste relative reference. All right, so let's change the size of it. So the size we're gonna do, let's do a B box, main, D underscore Y size. So this is gonna grab the fish's height and use that as a radius. So let's just use that to multiply 1.2. So just have some buffer area. And then let's make a line here. So the fish is here, and so the line, let's do a x direction. So 1, 0, 0. And then the origin. So what I want to do is, so for Y and Z, I'm just going to do centroid main dy, and then dz, and then dx. But on the dx here, we actually need to put the length in as well. So copy, paste relative reference, plus. And here you want to use negative 0.5, multiply this. Okay, so we get the here. And the length here, let's use the fish's length as well. So here, let's do B box, main, D underscore X size. All right, so it's going to use the fish length, and this is going to be at the center of the fish as well. And again, we need a little bit buffer, so 1.2 multiply that. Okay, so the idea here is just like how we did before, we're going to use the line to resample, generate some points, and then copy the circle to the line. So let's resample this thing. Segments 20. And then let's do a sort. So I'm going to reverse the point count. So it's smaller here and larger here. Okay, and now we're gonna grab one of those wrangles we did earlier. So it's somewhere down here. Yeah, this one here. So we're just gonna, actually, let's just grab this, this, and this. Let's just grab these three, copy, and then place it here. So we can, here we can just do 0. Just plug this in. Okay, we don't need this. So this wrangle is gonna try to delete more points towards the end of the fish and try to preserve more points around the head. And you can tweak these C's later if you want to. And now we just plug the circle into the points. And then let's do a ray here. And let's ray this to the main here. So here we're going to use the direction as normal, but there is no normal on the circle itself. So let's put a normal on this. So let's do a point wrangle. And let's just do vector normal equals to negative normalize vector p. Okay, so if you turn on the preview, okay, so it's working properly. All right, so it's hitting the fish now. And now we want to turn on the create point group, and then we want to turn on the import attributes from hits so that it will pick up the color. And now let's put a blast node and just blast the rehit group. We only want to keep this. All right, so let's merge that to what we have already. So this circle, it's fine, but I think it looks a little bit too even, and I kind of want something like this, like a curved shape. So let's work on the circle a little bit more. So let's try to curve the circle from the beginning. So let's put a point wrangle here. So what I'm going to do is, so let's create an attribute called flow offset. So first of all, we're going to need a amplitude or multiply. So this is the amount of how much it curved. And now we're going to decide which part is going to be curved. So let's do a channel ramp. And the ramp name is called height ramp. And it's going to use the relative to bounding box, the first input, and current position. It's going to use the relative to b box y value to map to the offset. And then we're going to put it on top of the original position. So here we're just going to set. So we're going to move this on x direction. So let's just do p.x plus offset. And then we're going to keep the original y and z value. All right, let's generate the channel ramp and everything. So for now, let's just put multiply like this. Okay, so it's the wrangle is working now. So what we want to have is we want to do something like And then we need a cabin ROM for sure. Something like this. All right. So you might have to come back, tweak this. Let's see. Something like this. Okay. And now when you copy it, it's like chips. And then read it again and delete it. And then we just put a add note here to only keep the points. And then we merge everything. All right. After we got all the shape, I still feel like I want a fade off of brightness from the head to the tail. So let's drop another point wrangle here. And let's put vector color, multiply by, let's put a channel ramp here. So we're going to create a channel ramp called fade off. And it's going to use the relative to bounding box, 0 current position. It's going to use the X to map to the fade off. And then we're going to probably need a multiply later as well. Okay, so let's put the multiply just as 1 for now. And then for the fade off, because we want the head to be brighter. And then let's change the curve to something like this. So this might get darker when you put the fade off on it. So let's just increase the multiply. Now this is ready to be driven by our animation now. So because these are points, and if you take a look at the geometry spreadsheet, and if you take a look at the ID, you can see that the ID it's not correct. So because when we animate this, we're gonna have to calculate the velocity of the points and the render motion blur in it. So it's better to just get rid of the or just do a point wrangle, and then just call it ID equals to PTNum. Okay, so this way we can put trail on it later to calculate velocity. And also, it's always going to be useful if we just put a rest position on it before we animate this. So in order to render this, we're going to need the p-scale applied to this as well, just like how we did with the contours earlier. Now we're done with the contours look dev. Let's take a look at how we can rig and animate the fish in the next video. In the previous videos, we finished the look dev of the fish. Now let's take a look at how we can rig this and animate it. So you can certainly start by using the traditional rigging way, dropping bones and then put controllers and do the skinning and that kind of stuff. But actually for this model, we can basically get away with using a wire deform. So we can just use one curve and then we can manipulate the curve to animate this. Because essentially when fish are swimming, it's just a sine wave or a cosine wave. So let's take a look at how we can do that. So we're going to animate the mane, and we're going to use the mane to drive the fins. So let's first of all put a wire capture, because before the wire deform, this is needed. And then let's drop a curve. So actually we can pick up whatever we used here. So this is grabbing all the length and everything from the mane. So let's turn on the view, show for selected nodes. All right, so here we just put the length back. Okay. So something like this. And then let's transform it. So let's just move on Y direction a little bit. Okay, and let's resample this. So let's put maximum segment 100, because you want the curve to be pretty smooth when it moves. And then because we're gonna animate the curve, so we're gonna need a ramp attribute. So let's put a point wrangle. First input, not the second. And just like how we did before, we're gonna do ramp equals to float. Let's convert the PT_num to a float, and then divide it by endpoints, the first input. All right, and let's look at the geometry spreadsheet. Okay, it's looking good. All right. And before we do anything, let's just drop a rest position node. It's always going to be useful at some point. Okay, so we're going to name this. Let's put a null here and just call this curve static. And let's plug that in the wire capture. And for the settings, I find that the function, I like to use the exponential bump to give me better results. Okay. And now let's drop a wire deform. The first input needs to be the wire capture. The second one is the static curve. And the third one needs to be the animated one. So let's put a null here. I'm going to plug this in the wire deform. Okay, and for the settings of the wire deform, let's just do transform, local frames, no transform. So we can just do a simple test. So let's just drop a mountain node on it. And you can kind of see that this is already working now. But of course, we're not going to do like a noise on the curve. We're going to do a very smooth sine wave. So let's put a point VOP and start working on the animation of the curves. Let's call this a wave VOP. So let's go inside and we need to grab the attributes of the curve. So first of all, let's grab the first input, point number. Let's grab the float, and let's grab the ramp here. And then we're going to need the rest position as well. So this is going to be vector 3 rest. So let's put a vector to float, because the plan is we won't really do anything to the y and the x-axis. We're just gonna create a noise and then add it on top to the z. So let's just do a float to vector again. And let's put a add node here, z here, and we're gonna plug this in. And then this is gonna be the position of the points. All right, so let's work on what we're gonna add here. So first of all, because this is a wave that's gonna traveling along the curves, so we're gonna do a add, and then add, and then we're gonna promote this, and this is gonna be called offset. So essentially, when you animate the offset, the curve, there's going to be a wave traveling on the curves. And now let's build a sine wave for this. Because we kind of want the whole curve to be one wavelength, and the value of ramp is 0 to 1. And usually sine curve for like a vanilla sine curve, one wavelength is 2 pi. So let's multiply constant, and here let's put 2 multiply $sign pi 2 pi, and then let's put a sine wave on it, and then let's do a fit range. Fit, because the sine wave gives you -1 to 1, but we have to decide how much this wave, the height is. So from -1 to 1, and let's promote the one of it. And then let's call this one amplitude. 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 And then what we can do here is actually let's put this on the max one, and then let's do a multiply constant, and then put -1 and plug this into the minimum. Okay, this is what we're gonna put in the add. So let's put this in add, and let's go outside and tweak this thing here. So right now the amplitude is not doing much, so let's put this. So let's put something like 0.3, something like this, and probably even less. So when you animate this offset, you can see that this is moving now. But there's one problem here. If the offset actually goes from 0 to 1, keep increasing, you can see that the animation starts from the tail, and it's kind of going backwards. So what we want to do is we actually want something like this. So just keep that in mind. The offset needs to be getting smaller and smaller instead. And there is another thing here. So we wouldn't really want a starting phase like this. We actually want to shift the curve a little bit. So let's go inside the wave, and so before we multiply 2 pi, let's actually add constant here. So this needs to be a float. Let's actually put a -0.25. So like a -1/4 of the whole wave. So something like this. All right, let's look at this one better. So if you go to 1 and then something like that. All right, and we need to add some other values to help this. So basically, so for different parts of the fish, how much it's curved, it's definitely different. So let's actually put a, so here after the ramp, let's put a ramp parameter here. And here, this one, let's call this fade off ramp. And then the ramp type, spline, can be ROM. And let's plug this into, so before we add it, let's plug a multiply here. Before we add it, let's multiply that. So basically, some area of the body you want it to be curved more, and some area you don't want that much curve. So here, let's do 1. So camera ROM, and then the start, maybe we want something like this. All right. So this way, the start doesn't, curve that much. And then if you watch some of the videos of how fish, especially like really large fish like this, when they swim, they kind of do like a pulse thing every once in a while. So for every cycle, they usually they curve really strong, and then the curve kind of have like a decay over time and continually gradually become a straight line. So we need something like a decay, overall decay for everything, not just for different body types, body areas. So under the multiply here, let's actually promote the third one. And here, let's call this a decay. All right. So of all these values here, this is static, that's fine. So we need to create curves for the offset and the decay, these two. And after we get an animation we like for these two, we're going to add an animation of global control of the fish as well. So how it swims in the world position. And also, other than that, we're going to have some other animation as well, such as the particles emitting from the tail, the forces for it, the fish disappearing and appearing in the scene, all kinds of stuff. So for scenes like this, when there are a lot of animations going on, I tend to like to use chops because it's really easy to choreograph everything. And it's really easy to edit, and it's procedural as well. So in the next video, we will take a look at how we can create the animation curve for this in Chops. In the last video, we set up a wire deform for the rigging part of this fish. Now this video, we're going to take a look at how we can animate the attributes to create the animation. Even though the curves we have here has 100 segments, we don't really need to animate every single one of them. We just need to animate like a threshold thing. So let's just create one point here. Let's do add and create one point. It doesn't matter where you put it. Let's do it attribute create. Let's just create one attribute here called ramp to start with. And then let's drop a null node here. And let's call this into chop anim. And then let's drop a chop net. Let's rename this chop underscore anim. Okay, let's go inside and let's go to the motion effects view. And let's drop a geometry node. So geometry is usually what you use to grab the attributes of a outside node, any node outside the chop network. So the soft node will be .. into chop anim. The attributes we're going to grab is the P and ramp, and they're going to be renamed to TXCYTZ and then ramp. So it will actually split the P into 3 channels, and we need this to be animated. So if you display it, you can see these. So here I turned on the, so if you go to graph, I turned on the graph per channel name, and then I turned on 8 graphs so you can see these channels separately. So sometime, maybe you want to see them all together, then you can do alt scope channel, so they will be just merged together. But for now, let's just keep them separate. And then let's drop a output node to serve as the output. And the geometry itself, we need to go to common and then change the units to samples. So for this case, because we're only just doing one sample per frame, so you can do frame, you can do sample, it doesn't really matter. Either way, it's fine. So let's change the channel here, frame range. So currently, you can see that So if you go here and then you click on this, the frame indicator, you can see that the animation goes from frame start to frame end. This might be okay for now, but the problem is later when we do some animations, we're going to need pre-roll and possibly post-roll as well. So for that case, it's always better to, let's use start end. So let's put 0 and 2 to 40. So we have like a enough pre-roll and post-roll for this. And here the sample rate. So here we have 24. So basically one frame one sample per frame. So if you want like a cleaner, like sometimes you probably have to do like a 48. So which is it's gonna do 2 samples per frame. But let's keep this for now. So let's put a no here. And then because we're gonna work on all these channels separately, so let's just do a delete node here. And it's just like the delete in soft level. So here, let's do TX, non-scoped. All right, so this is gonna be TX. So oftentimes, if you bring in multiple geometries, usually multiple points, they're gonna be named TX0, TX1, TX2, things like that. But because we only brought in 1 point, so the only number you're gonna see is 0. So that's why here I put star to isolate the TX for all the points. Same thing here. Let's just isolate the TY and then change this to Y. And let's just copy. This is TZ. This is going to be C. All right. And then let's isolate the ramp as well. Here, this. Here, let's call it ramp. All right. So the animation I'm planning is the fish is gonna swim, do like a pulsing of the tails, swim for a while, and then slowly go back to static, and then do it again, and then stop. So it's gonna be a cycle. So let's go outside actually, and go to the chop anim. So let's do parameter channels, edit parameter interface. So here, let's actually put a integer here. So let's call this cycle frames. So this is how many frames the animation is gonna be. So for now, let's just do 72. So in reality, you probably have to tweak this and make a play blast, and then tweak it again, and just repeat until you get something you like. So let's go back here, and let's drop a expression here. So a lot of things you can just do it by doing expressions. So let's go to expression here. So let's do a, let's use the indexed index number +1, and then modulo by, let's copy parameter, and then paste relative reference. So just like how we did the volume, so you can hit this one, toggle vertical adapt, and you can zoom in. So just like what we did was the modulo for the volume. So you're gonna get this kind of like a ramp thing for each cycle. So this is gonna be a starter for everything. Now let's use a trigger node. So what trigger node does is you can get a value whenever the your curves start increasing. So for example, it start increasing at here. So when you do the trigger, you can see that we have this little bump at the beginning. So that's telling you that when this value increasing started. And then let's actually take a look at this. So if you turn on this as well. So we don't really need, so this thing is very, I mean, there's too much stuff going on. And let's actually go ahead and change some of the values here. So first of all, let's go to common, and then here, units, you want to do samples or frame. And then here, the attack, you want to do attack length 0, and then peak length 0 as well. And then under the sustain, you want to do decay length 0. So we're just basically just killing all the stuff you don't need. Sustain level, release length, all 0. Yeah. And then, so now you can see that, so it's really, it's only just give you an indicator of when everything starts. Okay, and the value is from 0 to 1. So now let's just copy this trigger and paste after this. And then this time we're going to keep everything the same, except that for the attack length, let's go outside and just copy cycle frames and paste relative reference. Okay, and then so basically what this thing does is, let me actually rename this. Right. So what this thing does is when the animation starts, you're gonna have this curve here, and we want attack shape to be linear instead, because the built-in easel animation, sometimes you probably don't want this, and we're gonna use our own way to adjust the animation curve, the ease out. So the way we're gonna do that is we can bypass this now. So let's drop a lookup here, and we plug the first in, and we're gonna change it to all lookup table channel, and then in the second input, we're gonna create a customized animation curve. So the way you can do that is, let's drop a null node and just call this anim1. And then, so this time, let's go to parameter channel. You can ignore the error, it's fine. So let's select that and just say invisible. And we're just gonna put one float here. And let's just name that channel anim. Apply, accept. All right. And this time, let's go to actual animation editor. So, so we have this kind of curve in motion flex view, and it's, to be honest, it's really the same as the animation curves here. So however you view the animation curves here, it's the same essentially in the motion flex. The only difference is just they're procedural. That's it. So let's go to animation editor, and let's do some animation for this. So let's go to the frame start, and then just hit Alt, left mouse click to key it. And then let's go to the last frame and put 1 here and just key it as well. So let's click that, and all right, so we get this curve here. And then let's go to somewhere around here. Okay, and then let's put a 0.62. Okay, let's left mouse click to key it. All right, and now we can adjust the handle of the animation curves. So we get something like this. So a little bit easy in. All right. And now we can go back to the motion effects view. You can ignore the error. It's fine. So let's drop a fetch node. Sorry, the other one, the fetch parameter here. So geometry is being used to grab attributes from outside the chop, and fetch is something that you can use inside to grab a specific chop node. So that's the difference. So let's do fetch the node. Let's put // nm1, and then the channel. Let's just call it because the name we name this is anim. All right, and then let's just plug that into the lookup. So here, let's do graph all scope channel. All right, so you can see that this is something that we get. So after the lookup, so basically it's using however settings we have for the anim to get a customized ease in, ease out curve. So if you don't like it, if you want this value to increase faster or slower, all you have to do is you can go back to the anim and just tweak this handle here, and then it's gonna update the curve for you. So remember that when we were setting up the rig for the fish, the offset needs to be a backwards, like a negative value. So here, let's actually put a expression here, and let's just say negative value. So we get a the value just start to decrease every time in every cycle. Okay, and the next thing we need to do is right now, if you middle mouse click, this is called ramp 0 anim. So we need to rename this properly. So let's put a rename. So it's called ramp 0 anim. Okay, so from ramp star anim to offset star. So if we have multiple points, what this does is we're going to get offset 0, offset 1, offset 2, things like that. And then we can grab the attributes from outside. So let's go outside here. So the way you can grab a value from a chop net is that you can drop a channel node here. Let's call this channel anim, because we're going to use this to put this in a lot of the nodes. So the chop would be // chop anim output. Actually, let me rename this so it's easier to grab. Okay. And the method should be animated. And because we didn't do anything with the position and we didn't plug it into the output node, so let's just forget about it. Let's just grab the channel, the offset channel, and let's put a attribute scope here. Let's call it offset. And it's going to give you error, and the reason is because we don't have an attribute called offset. So let's go to the attribute create and just create a new attribute and just call it offset. So now if we make sure that this is real-time playback, and then let's go to the geometry spreadsheet, and then let's just hide all the attributes and only keep the offset. And then if you play this, you can see it's basically decreasing for every cycle. Okay, So what we can do here is let's go to the wave swap in here. Let's just put point expression here. So point dot dot slash channel anim. The first point, so it's 0, and then offset, and then the first digits. Okay. So now, if you look at the curve, you see something like this. And if you think this is too slow or too fast, you can always tweak the chop. All right, so now we have this, and let's continue work on the decay. So let's go back to the chop network and go back to the motion effects view. So we already have lots of stuff going on, so we can really just start from here, from when we put the value multiplied by -1. So let's start from here. So let's put a expression here. And here, let's do +1. Okay, so it's still a decay, but it's 0 to 1 now. And then let's put a filter node. So what filter node does is it's going to smooth the curve, smooth out all the these sharp spikes. So for the filter, let's go to common, and the unit really matters for this mode. So let's change it to samples. And then here, the filter width, let's put 10. So you can see that it's filtering this thing here. And then let's put a rename there. So we can just copy, paste that one. And then let's just call this decay start. All right. And then let's just merge these two. So we have offset and decay. And now we just go outside. And then here, again, we need to just add a attribute called decay. And we don't have to write the value or anything. And then in the channel anim, so you just put decay there, and then decay here. Okay, and then here, we're gonna just copy this expression, paste it to decay, and then we're gonna change the offset to decay. All right. So let's see. So we get something like this. So once we have this, we can use this to drive the fins now. So all you have to do is let's just drop a point deform. So the first input needs to be the one we use to deform, which is the fin, the static. And the second one should be the original main. And then the third one needs to be the wire deformed one. All right, now let's just merge these two. So here, I'm gonna pause and run a animation flipbook to see how the animation looks like. All right, so this is something we have. Not bad so far. So in the next video, we'll continue to work on the global transformation of the fish. In the last video, we created in chops a swimming cycle for this fish at the origin. Now let's continue and add the global transformation. Let's go back to the chop anim and turn on the motion effects view. So we already have the animation cycle set up. So we can, so let's start from here when we already, so this is the first trigger and this is the second one. So let's start from the second trigger. So because we only want the fish to swim on the X and Y direction, so we don't really have to do anything with the Z. So we can just put a merge, and let's just put the Z in, and then let's just merge that to the output. And then let's work on the X and Y. So let's go outside first, and let's do parameter in channels, edit parameter interface. And let's put a separator here after the cycle frames. And then let's put a float here. So this one, let's call this X underscore offset. And then X offset. And then let's do another one. This Y underscore offset. The label is Y offset. All right. So we're going to kind of figure out in one frame or one cycle, the chops, how much you want the fish to move when it's moving. Because remember, we're doing like a pulsing, so it moves a lot when the tail is wiggled, and then it kind of slowly fade off, kind of thing. So the way you can get a value here is that you can do, let's say, for example, if we do 200 frames, and then you can kind of see that how far you want the fish to move. So let's say if you want it to move like 0.5 and then divided by 200 frames, you want it to move 0.5 on Y direction, something like that. And then you can just copy the Y to X, and then let's do maybe like a -2. So we just control the X by using the Y. So let's leave this value for now. This is something that I kind of like. So let's go into the motion effects view here. And let's start from the second trigger here. So we're going to use another lookup and fetch and anim as well. So we might as well just copy these and then paste here. And then let's reanimate this one. So let's just delete channel for now. And let's go to the animation editor. And because for this one, the animation, you want like a higher value at the beginning and then gradually fade off. So let's put 1 at the frame start. And then frame end, let's put 0. Okay, something like this. And then let's go to somewhere around here. And then let's put a value like 225. And then key it. All right. And then let's tweak the handle a little bit. So something like this. All right. So now let's go back to the motion effects view. Again, you can always tweak the handle to something you'd like. So here you can see that when the animation starts, the value is gonna decrease like this. So let's bypass that. But keep in mind, this value is how much it moves. It doesn't necessarily means the sum of how much it moved. It just means how much it moved per frame. And also, right now the value is only just 0 to 1. But in reality, let's say, for example, if you want this side to be really high, and the side to be really low, what you want to do is probably put a expression here and actually just keep multiplying this. So we can do fit value from 0 to 1 to 1 and 5. Something like that. And now let's go ahead and multiply the x and the y offset we had earlier. So let's put a expression here. All right. So here, let's do, let's go up and just copy parameter, go back, and then multiply, paste relative reference. Okay. Even though, because this is a negative value, so you get the curve just got like reversed somehow, but that's totally fine. And again, what we are having is how much it moved per frame. This is not the sum of the whole distance. So what we need to do is let's drop another expression here. And here, let's do value plus out channel 0 index -1. So what this thing does is first, it's going to grab the output of the first input, which is this one. So basically, it's the current channel. And then $i, the index number is basically the frame or the sample number in this case. So it's going to grab the previous output value and then add it on top. So basically what we're doing is, let's say the current index is 1045. What this one does is every frame, you're going to add the result of previous frame. So it's going to keep adding this node on top. So that's what we get here. It might be a little bit confusing at the beginning, but this expression is very helpful in a lot of cases. And now we have another problem. Because I wanted to have some kind of pre-row, post-row for the animation purposes. So our animation actually starts from 0 to 20 to 40. And that's going to cause a problem because this frame range starts from 1001. So what we're going to do here is let's put an expression here. We need to subtract the value at that frame. So we use the position at 1001, we use that one as the starting place. So we need to use the current value minus incoming channel 0 means the first input. 0 means the first channel, and then 1001. So it's gonna, you can see that here at the frame start, the position is 0. Okay. And now we're done. So all we need to do is we need to rename this thing. So let's just plug this in. Currently it's called ramp anim. So let's just do ramp anim. Let's rename this to TX star. Okay. And then now for the Y direction, all we have to do is we can just copy this and paste here. And then here, instead of multiply X, we just multiply the Y offset. And then again, it's gonna do all the stuff, subtract the value at frame start and rename it. Yeah, rename this thing. Okay, I'm gonna rename this to that. And then let's plug this into the merge we had together. All right. Now let's just bypass these two. Okay, so we have the TX, TY, TZ now. And just to make sure, because we don't want the TZ to move at all. So let's just put an expression here. And let's just make sure this is 0. All right. So now we can go outside. So we don't have to create a new attribute or anything. We can just put the channel scope here. So let's put TX, TY, TZ, because the channels are split it into 3. And then the attribute scope, we're gonna put it in P. All right. So if you look at this, you can see that the position is changing. And now let's go back to where the fish is. So here, let's drop a transform node. Let's color this. So we want the fish to swim on, like, tilted up a little bit. So let's just rotate this slightly. And the pivot transform. So just be safe. Let's use the so let's move this to the back of the main. The minimum. And then these, we're gonna use the centroid. Let's see. Right. Okay. And the translate. So let's go ahead and grab the curve we just did. So the way is we're gonna do a point, and then it's gonna grab the channel NM, and the first point, we only have 1 point anyway. And then it's gonna be P, and it's gonna be first digits for X, and then let's copy that and put it in Y. It's gonna be the the second digit, which is the Y, and then the third digits, which is the Z. Okay, so we get something like this. Again, you probably feel like, oh, sometimes it moves too fast or too slow, or you don't like the rotation angle and everything. You can go ahead and go back and tweak, and you can change the cycle frame as well. You know, maybe you want it to be faster or slower or anything. So once we have the animation of the original mesh, we can go ahead and so let's actually rename this. Let's put a null here. So let's rename this body anim. And you can even cache this one out, because we're going to use the animation a lot in other nodes. So we can go back to, you can either go to the one that we had the box volumes, or you can go to the one that we made the, not this one, the contour line. So let's just try the contour lines for now, because this one is faster. So what you can do is you can do a point deform. So after you already, this one we already have the color, but for the box volumes, you want to grab the color first using the point cloud. And then after that, we can use the point deform. So you can plug the first output in and then do a object merge here, and let's call this OM body static. So we had a node. We can grab the body static in. So we had this static geometry here. So you plug this into the first one, and then let's just copy that, and and change it to anim. Anim. So it's here. Okay, and then you just plug the second one in. Once we get the animation of one fish, now I'm gonna pack it and get a animation of 4 fish instead. So here I'm tweaking the position. I decided to do a little bit time shift, and then I dropped part of the animation cycle as well. So here you can certainly do a copy 2 points, but actually I want it to be a little bit uneven. So I time shifted each fish. So I want the time gap between different fish to be kind of different. You know, sometimes you get 2 fish, sometimes you get 1 on the screen. And I put a the attribute called fish_ID to each one as well, so that we can use that later. And I'm just changing the timing and the position of it to get something I like. So you don't want the fish to overlap with each other for sure. So once we have something like this, if you have a farm, you can certainly just do animation of 1 fish and then just do 4 objects and then send them to the farm at the same time. But for this case, I'm just going to copy paste the whole network and then just copy paste relative reference to all the time shift and the transform node. And I'm going to put this one behind under the contour and the voxel box nodes we had earlier after the points before the volume. So this is the final result of all the fish put together. Now we're going to take a look at how we can add a particle simulation of the trails in the next video.